In this video, I am going to completely introduce you with a MongoDB device sync service. So let me show you the end result of this tutorial. So this is the same application that I was using in some of my previous videos about building a local database with a MongoDB realm. And in this video, however, we're going to use the same project, but with only one difference. We are going to utilize a device sync service in order to synchronize our local data with the remote database on a MongoDB Atlas. So a MongoDB Atlas is basically a platform where we're going to host our remote database, and this is our actual database and our collection. So from our application, now we're going to actually authenticate with Google and create a new user on a MongoDB Atlas. So let's sign in here with Google. Okay, there we go. So now we are signing in. And after we successfully authenticate, we're going to navigate to our home screen. And from there, as you can see, so far our actual home screen is empty. So let's try and actually add one new item in our local database. For example, with the name of my own name. Let's press add button, and as soon as I press add button, a new item will be immediately stored inside a MongoDB local database on our Android device. And also, if there is an internet connection, then that change will also be pushed automatically to our MongoDB Atlas on our remote database. And since we actually have that internet connection, then that change will immediately apply to our collection remotely. So let's add this new item. As you can see, that item has been added locally, and now let's check the actual remote collection, and we should be able to see a new item. There we go. So now we can see that same item in our remote database as well. So what we can do from here, we can also just try, for example, to change one of those properties from that remote database. For example, let's rename this name to say John. Let's click update. And as soon as I press update, then that change will be immediately pushed down to all our clients that are actually observing that same data. As you can see, now that name has been successfully changed. We can also update all of that all from our actual client application. So let's just copy this object ID. Let's now change the name of this, for example, to a Nick. Let's click update. Let's now refresh this actual collection, and there we go. So everything works here as expected. Now, one thing to point out here is that if we, for example, do not have an internet connection, so let's now disable this internet connection. And if we try to, for example, now maybe even delete this actual element, as you can see, that element will be successfully deleted. But if we refresh this database or this collection in our remote database, then you will see that that item has actually not been removed. And why is that? Well, because in our device, we actually don't have an internet connection. So that change was applied locally, but not remotely. And immediately after we actually enable this internet connection back, then this MongoDB Realm SDK will automatically push that change on our remote database. So now we have received that connection back, and now let's try to refresh this actual collection. Everything works as expected. So with a MongoDB device sync, you will be able to implement a data synchronization very easily. And for example, if you specify here one of those elements, or actually add one of those elements inside your database, and you decide to actually remove this application from your device, let's just try to uninstall this application. So even though that application has been removed, that actual data will still remain on our backend or remote database as well. And now if we install this application once again, and we log in with the same account, then that data will be immediately retrieved from our backend database. And that way we will not lose our data even if we delete our application. Okay, so now you have seen how this application and this device sync service actually works, which means that now we can get started. Okay, so the first step in integrating a device sync in our Android application is to actually create an account on a MongoDB Atlas. So here I have already created an account, and I'm going to go to sign in. So I'm here signing in with my Google account, and after we are successfully logged in, then we need to create here a new application. So at the moment I have one application, a diary application that I have already made for the purpose of my online course. And now let's create here a new project. Let's give a name to our project, for example, test app, right? Go next. here we need to select the actual owner of this project. In this case, that will be me, so I'm the only one here. Click create a project, and there you go. So now we have successfully created a new project on a MongoDB Atlas. The next thing here, as you can see, as soon as we create a project, we're going to see a message saying that the current IP address is not added, which means that we will not be able to connect to our database from our current IP address. So click this Add Current IP Address button. So now we have successfully specified our own address in this network access panel, which means that, for example, when we are connecting to our MongoDB Atlas or a cluster using a MongoDB Compass, let's say, we are going to be able to do that only from our own computer. Otherwise, even if you have that connection string to connect to this MongoDB Atlas, that connection will be denied if you try to connect from some other IP address, okay? Now the next step is to actually create our database. So let's create this database, and this database will be used as a remote database that will be synced with our local database on Android. Now there are different options here to choose from, and of course we're going to choose this free option. So we have around 5 megabytes of storage for free, right? So it's a great thing for smaller projects. And down below we can also choose the region. For example, I'm going to choose Europe because I'm in Europe, and we can also specify the name of this cluster. So basically a cluster is a place where our database will be located. So just specify the name of this cluster and press create. There you go. So now the cluster is actually building, and while that is in process, we need to set up the username and password, which we can use later to actually connect to our MongoDB cluster remotely, okay? So in this case, I'm going to just generate here a username, for example, that one, and I'm going to specify here a different password. So just click create a user, and later we can use those credentials, username and password, to actually connect remotely to our MongoDB Atlas by using a tool called MongoDB Compass. But nevertheless, for now, let's just continue, and down below we also need to specify, of course, this IP address in our network access list, but since we have already done that, we don't have to repeat that step, and we can just now go click finish and close. Go to the dashboard, okay, and now our cluster has been successfully created. Now this actual cluster will contain our database. So what we can do now, we can also just go to this browse collection to actually browse and see what kind of collection or database we actually have here. So at the moment we don't have any database or any collection, which is why we need to create here a new database here. So click add my own data, and for the database name I'm going to type here, for example, people, right? So that will be the name of our database. And for the collection we can just write, for example, a person, so with the lowercase letter in this case, and click create. So now you'll see that here a new database named people and a new collection named person has been created, okay? So this collection is at the moment empty, and this collection does not contain any collection schema. And of course, if you want to create your collection schema, there are two different ways to do that. So the first one is by manually defining that collection schema by yourself, and the second way is by using a development mode on MongoDB Atlas to generate that collection schema automatically as soon as you sync your project with MongoDB Atlas. So let me just open up the App Services panel from here, so I can show you the actual schema. So, okay, so here we have an option to choose whether we want to start building our own application from scratch, or to choose some of those templates for example, a real-time synchronization. In this case, let's do that from scratch. So just select this option and click next. Okay, so this is our actual cluster. We can now specify the name of our actual application. For example, test application. And from here, of course, we can leave that as it is. So now let's create our app service. Click that button. There are different kind of guides that we can check out here, but for now we don't need that, so let's just close that. Okay, perfect. The next thing here in this app services panel, we have different options, like for example the rules or the permissions that we can create for each and every collection that we actually have in our MongoDB Atlas. We have a schema, so this is the place where we actually define the schema of our collection. In this case, as you can see, we don't have any schema, but we can define that manually by using the JSON format, but we're not going to define that schema manually by ourselves. Instead, we're going to use a development mode of a device sync service to actually automatically generate this collection schema when we actually sync this remote database with our Android application. Now, here in this app services, we also have a app users section where we can see all our users. In this case, we don't have any user. Then here we have the authentication section, and this is the section where we can decide what kind of authentication provider we're going to have for our application. In this case, for this video, we're going to choose a Google. So just open that up, enable this provider. And there are a couple of different things that we need to enter here, like for example the client ID and the client secret. And those two credentials are obtained through the Google Cloud Platform. So now we need to go to the Google Cloud Platform and actually generate those credentials in order to being able to actually authenticate our users by using their Google account. Now, down below we also have some option to check what kind of metadata fields we want to store in our users database whenever a user tries to authenticate with our application. But at the moment of recording this video, there is a certain bug with MongoDB which will actually not allow us to specify those fields with a Google Cloud or a Google provider, right? So instead what we need to do, we need to just check this OpenID Connect, and then those fields will actually be disabled. So if you want to retrieve those actual fields for each and every user that authenticates with your application, then you are going to need to select a different authentication provider, which will be a JWT. But for now, we are going to use the Google provider, and in some of the next videos, I may create a totally separate video explaining you how to achieve that. For now, let's just continue, and I'm going to now open up a Google Cloud Platform. So here you need to create your own project, okay? And I have already created this project, as you can see here. Now I'm going to go to the APIs and services, and then the library, or actually credentials. And inside this credentials page, we need to create two different clients, Android and the web. So to create those credentials, you can just click this button right there, and you can select Auth Client ID, where you specify the Android. And when you are specifying the Android client, then you also need to add the package name of your project and the SHA-1 certificate fingerprint. So let me just open up the Android Studio project so I can show you how to generate that SHA-1 certificate fingerprint. For the package name, of course, you can just copy that package name. And for the SHA-1 certificate fingerprint, you need to open up this Gradle section, then click this execute Gradle task button, and here we need to type one command, Gradle, then a space, signing report. And now press enter. And then here we're going to generate that signing report, and we can obtain that same SHA-1 certificate fingerprint that we can just paste on that Android credentials in a Google Cloud Platform. There we go. So that's how you can generate that SHA-1 certificate fingerprint. Perfect. Let's go back now, and you can just enter those credentials right there and click create. The next client ID is a web application, and for that you don't need anything, you can just click create button, okay? And of course I'm not going to do that since I have already made those two credentials, and the actual credentials that we're going to use are from this web client, okay? So not Android but a web client. So open that up, and here I'm going to copy this client ID, copy, and then let's paste that right here. Okay, and then this secret, so this secret key, so copy that one, and here let's create here a secret, for example with the name of a secret, press enter, and then for the secret value just paste that right there. Okay, so after we have saved all of that, so after we have specified the client ID and the secret, after we have enabled those two options, now we can click save draft. Okay, so just click next, got it. There we go. We can now press review draft and deploy to actually deploy those changes. So click deploy. And now we can go back to our authentication provider here. And as you can see now, this Google provider will be enabled. Also, this same client ID that we have just copied will be needed in our Android Studio project. So let's just open up our Android Studio project, and don't worry, I'm going to later introduce you with this actual project itself. Let's just open up this constants object from here, and we need to paste that same client ID in our project. So just paste that right there, because this client ID will be needed to actually authenticate our users with their Google account, since we're going to use one-tap sign-in API for that purpose. And we also need one more constant in our project for later, and that is the app ID of our MongoDB Atlas application. So let's just go back to our project. Let's click on this test application right there, and we need to copy this app ID. So just copy that and paste that as a constant. There you go. Okay, and for now I think that we have set up almost everything we need. So we have created our actual database, our actual collection. We haven't generated the collection schema because we are going to do that automatically later, so don't worry about that. We have specified the authentication, and now let's open up this device sync panel. So this device sync will be able to synchronize our actual data from a MongoDB Atlas with our Android application. So let's click Start Syncing. For now, just choose No Thanks, Continue to Sync, because we're going to generate that schema a little bit later. Okay, and this is now the panel of our device sync. So the first thing that we need to do here, we need to choose this flexible recommended way of syncing the data. Then after that, we need to choose and actually enable this development mode. So with this development mode, we will be able to actually generate that collection schema automatically. I'm going to show you that later. And here we need to also choose our actual database that we have already created. There you go. The next is the queryable fields section. So basically queryable fields will allow us to query all our collections from our database by using that same field that we have specified right here. Now in this case I'm going to also add one more queryable field. So a default one is the ID, which will be a unique identifier of each and every document inside our collections. And so far we haven't actually generated a collection schema in our MongoDB Atlas. However, since we have already enabled this development mode, we are able to add here one more or some more extra queryable fields that are actually not present yet inside those schemas. So in this case I'm going to add here the owner underscore ID, and now press enter. So the owner ID is actually not in our schema, okay? Since we haven't generated that schema yet, but don't worry. And the owner ID will represent basically a unique identifier of each and every user in our application. So why is this queryable field actually important? Because later, when we start with our Android Studio project, we are going to subscribe our actual user to this same field. Okay, and when I say subscribe, I mean that later in Android Studio project, we're going to subscribe to this owner ID queryable field, which will mean that we're going to sync our data from our client with our remote database by using this queryable field. Okay, so you will see all of that later. For now, what we can do, we can just click Enable Sync. So just click Enable Sync. Okay, so here a new pop-up has shown up, which means that we haven't actually defined the permissions for our roles, and we need to choose one of those preset roles. I'm going to choose here user can read and write all data, but of course later I'm going to change that. So just click add a default role. Okay, now press this review, draft and deploy button, and click deploy. Alright, so now our device sync has been enabled. Anyhow, with this device sync enabled, those rules has been automatically generated for us at this point. So just go to this rules panel, just go next, got it, okay. And as you can see at the moment, here we have of course our database and our collection. So for this default preset role, we have specified a read and write all, but we can add a different one. So we can now specify here other preset, which is a read own and write own data. That will mean that each user will be able to read and write their own data. So just change that preset now. Select this one and add a preset role. So read and write own data. And now we can remove this first one, a default one. So read and write all. Just delete that role, there we go, click Save Draft, and with this enabled, users will be able to read only their own data. And now we can also select this person collection and add that same role as well, so read own and write own. There you go, perfect. So the last thing which is needed here in our MongoDB Atlas is to actually generate those or that collection schema for our person object. But we are going to start that after we actually introduce with this Android Studio project. So the thing is, I'm actually using this project from one of my previous videos that I have made on YouTube. So if you haven't watched that video about building your own local database on Android with a MongoDB, then I highly suggest you to actually watch that video, because in that video we are using this same project. The only difference is that this actual project has been modified a little bit to support and enable MongoDB device sync. And now I'm going to go through this project and only show you the differences that we have made to actually enable that device sync from a MongoDB. So the first thing, as you can see, we have specified here a new permission, which is the internet permission, because we're going to need this permission if you want to sync the actual data with that remote server. The next thing, let's open up the Grail build file. So here I have specified a new library here for a MongoDB, which is a library sync, and we are no longer using this base library. Now we're using this sync library. And also I have specified here two dependencies. The first one is message bar compose. That's actually my library that actually just allows us to display a simple message bar in our screen. And the second one is a one-tap compose, which will allow us to actually implement one-tap sign in with Google in our composable project very easily. Also, if you're planning to use those same libraries like this message bar compose and a one-tap compose, then you are going to also need to add this Jetpack.io repository in your settings Gradle file. Now let's close all of that. The next thing, I want to open up this database module and explain you one important thing. So in that project from before, when we have actually specified MongoDB only as a local database, then we have described and actually provided this Realm instance from this Dagger-Hilt module, okay? However, now when we are using a device sync, this Realm object or this actual configuration needs to contain one more additional parameter, and that is the actual user, okay? However, our user cannot be provided immediately after we launch our application for the first time, because we first need to authenticate our user. And that's why in this case, we're no longer going to be able to provide this Realm instance from a Dagger-Hilt module. Instead, we need to create our own Singleton, and there we need to call that new Realm configuration with a new parameter, which is the user. Okay, so we're not going to use this database module anymore. As you can see now, this is our Mongo repository, which contains one new function, configure the realm. And this is the function which will allow us to actually configure that realm by using the user. So let me just show you that. So this configure the realm function will be triggered immediately after we call this MongoDB object. And this object will be called only after we successfully authenticate with our Google account. And after we successfully authenticate with our Google account, then that's when we are going to call this object, and then this user will be actually available. So here we are first, of course, creating this application by passing that app ID, and then we are extracting that current user from that app as well. And that user will be used to actually build our sync configuration. So as you can see here, we are also calling this sync configuration, and we are passing our user along with those model classes or this actual collection and those two embedded objects as well. So I'm going to show you those model classes a little bit later. As you can see in this configuration, we are also calling one a function which is the initial subscription, and there we are adding our actual subscription. So as a query, I am specifying the owner ID, which is the field that our person collection will actually have. And with this function, we are basically subscribing to to our MongoDB Atlas, which will mean that the data that will be synced from our Atlas to our Android application will be only the data which owner ID is our own current user. So basically we're going to only sync the data that we have created by ourselves. So that's the whole point of this subscription right here. And if you want to read more about this subscription concept, you can also check this documentation. So when you configure the flexible sync on the backend, you specify which fields your client application can query. And in this client application, we use this subscriptions API to manage or set the subscriptions to specify queries on queryable fields. And when you create a subscription in your application, a realm will look for the data matching a query on a specific object type. And you can create multiple subscription sets on different object types and even query multiple times on a same object. Okay, and in this sync configuration, after we are specifying that subscription query, we are also just specifying here that we want to log everything from this realm SDK, and then we are just building our actual realm. So that's the reason why we don't. So that's actually the main reason why we cannot provide our realm within our Dagger-Hilt module, because in this case we need to pass the user, and this user will actually be available only after we successfully authenticate. Now below this function we also have some different functions to get all the data, to filter the data, to insert the person, to update the person, and to delete that person as well. So as you can see, in this case we're just querying our person collection and we are returning the flow. Then in this function we're just filtering the data to select only the person objects that contain the name which is similar to the one that we are passing right here. Then we have a function to insert the new person object in our actual collection. As you can see, in each and every case here, when we actually need this user in the query, then I'm using this if block to check whether this user is actually not null. And of course, when we are creating a new person, or when we are adding a new person to that MongoDB collection, I'm also applying here that owner ID field to be the current user which is authenticated. And that's how we can mark each and every person document in our collection with a unique owner ID, which is referencing each and every user. Down below, as you can see, we have a update a person function, which basically just updates our actual person object by changing its name. So in this case, we are only changing its name, but we can also apply other different properties as well. And of course, a delete person function as well. So that's how MongoDB object will look like. Alright, so the next thing, let me just show you how our collection schema will actually look like. So this is the person class which implements this realm object, and basically is the same class that we have with that previous project that I have made a separate video for. So this realm object means that this person class will represent a collection, and down below we have two embedded objects that implements the embedded realm object. So those two objects will be nested within this person collection, and basically that's how we actually define our collection schema. So I have already specified and told you that we're going to use our actual Android Studio project to generate that collection schema automatically by using the development mode on our MongoDB Atlas. So here everything is the same from that previous project that I have already made for the local Realm database. Only this time, when we are implementing a device sync service, we need to add one more property within our collection, which is the owner ID. And I have already talked about this owner ID, so it will represent a unique identifier of each and every user when we are creating here a person in our database. And before we actually automatically create and generate that schema on our backend or on our MongoDB Atlas, let me also show you a couple of different things that we have also specified within our project. So the next thing is our screen class. So we have only two screens. The first one is the authentication, which will be displayed only the first time we are launching this application, and once we authenticate, then next time we launch this application, then the home screen will be actually triggered and shown to our users. As you can see from this main activity, we are calling this setup nav graph function to create our navigation graph, and as a start destination we are dynamically calculating whether to set the home or authentication route as a start destination based on the fact whether if our user has been authenticated or not. So that's how it works. And let me just show you now that navigation graph composable function. So we have two different routes, authentication route and a home route. So the authentication route contains the authentication screen, which contains the actual components to trigger that one-tap sign-in. So whenever we press that Google button, we are triggering this one-tap sign-in dialog. And this set loading will basically trigger the loading of our Google button. So if we are successfully authenticated with Google, then we are triggering this function signing with MongoDB Atlas, which is the function from our authentication view model. As you can see, that function basically uses this login function from our MongoDB Realm SDK, and we are passing a Google credential to actually sign in with Google on our MongoDB Atlas. And then as a result, I'm grabbing this logged in value, and if that value is true, it means that we are actually now successfully authenticated, in which case I'm calling this onSuccess lambda, which will basically just display here this message bar, successfully authenticated, and after a delay of 600 milliseconds, I am changing this value to true, which will immediately navigate us to the actual home screen, okay? And of course, if we receive here some error, then we are displaying that error and we are specifying the loading state to false. Below that, we also have the home route. So in the home route, we are just basically observing that data from our MongoDB, and we are displaying that data to our home screen. Here we also have a couple of different functions to actually insert, update, delete, and filter our data. As you can see, let me just open up the home view model. So whenever we initialize this home view model, and that will be when we actually call our home screen, then immediately we are observing that data from our MongoDB, and we are updating our UI. And down below, we are just calling this MongoDB object, which we have already made, to actually trigger those functions like the insert person, update person, delete person, filter the data, and so on and so on. So basically, that's how this project will look like. And now I'm going to show you how to generate that collection schema automatically by using the development mode of a device sync. So now I'm going to launch this application actually, and we're going to try to authenticate with MongoDB, okay? So after we successfully authenticate with MongoDB Atlas, then we're going to navigate to our home screen. And inside the home screen, we are going to trigger this MongoDB for the first time. Okay, so in this home view model, we are calling this MongoDB for the first time, which means that this object will be initialized after we open up the home screen. And that's where this configure the realm function will be triggered. And when this function is triggered, then that schema will be automatically generated on our MongoDB Atlas. So let's just launch this application. Let's just wait until that Gradle completes. Let's press this sign in with Google button, and as soon as I click that, the loading state will change to true, and our Google button will start loading. There we go. So now we are also triggering that one-tap sign-in dialog. As you can see, we are now successfully authenticating with the MongoDB Atlas, and a successful message has been displayed. Okay. Now let me just go back to our MongoDB Atlas. Now I'm going to open up the app services. And then I'm going to check the actual schema tab. So let's just open up that application first, then a schema. And you are going to see here a new schema and a new collection, which is called person. So this is our old collection that we have created manually by ourselves. And this is the new one, which was automatically generated when we have actually initialized or called that configure the realm function. And this person, let me just open it up. As you can see, that schema was automatically generated, so we don't have to declare that JSON by ourselves. We have generated that automatically. So as you can see, it contains different types like the ID, owner ID, name, age. Then we have the address, which is the embedded object. That contains other different nested fields like the street number, street name. We have pets, which represents a list or an array, and so on and so on. There we go. So now let's open up the data services, then the database, and open up that cluster. So this is our collection, so people.person. And now let me just try to actually add here some actual item or a person to our database. So if I now click here add, then you will see that a new element has appeared, okay? So now if I refresh this actual collection, you will see that a new item should also appear here. Okay, so I have forgot to specify or actually delete that old collection, because a new collection has been automatically generated by our SDK when we have triggered that insert function. Let me just remove this old collection, so lowercase letter p, so person. Let's drop this collection. Okay, now open up this new collection, and this new collection will have that object that we have just added. Okay, so right now I'm only modifying and actually adding one property of this person object, which is just the name, but of course you can also modify and specify all other different fields as well. So there you go. Feel free to comment down below and let me know what you think about this device sync service of MongoDB. Also, be sure to comment down below if you have any questions about this tutorial specifically, and be sure to like this video, but only if you find it helpful. For this video, that will be all.